Well, thank you for allowing me the opportunity to introduce to you the PACE TF2700 Rework System, which is made in the U.S. right here in Elk Ridge, Maryland. What I'm going to do for demo purposes today is give you a brief overview of the hardware on the machine as well as the software. And then I'm going to show you the steps for alignment and installation of a new component. We'll then discuss thermal profiling and profile development on the TF2700. And then we'll finish up with a component removal. So first things first, again, this is the TF2700, TF standing for ThermoFlo. Our machine is a convective unit using hot air on the top side to heat the component. And then we use a medium wave IR bottom side preheater to heat from the bottom as well. The heater head, which is this assembly here, does house the, as it sounds, the heater, our convective heater. And on the head, in order to direct the airflow where we need it to go, we use what we call our component nozzles. We have over 50 component nozzles which are sized to the component that you're using. You don't necessarily need to be exact to the component dimensions. You can always be a little bit larger, assuming the real estate on the board allows for that. So here's a couple examples of the component nozzles. As you will see, they are vented, which promotes thermal airflow and efficiency. So on the heater head, to change a nozzle for our various size components, all we simply do, it's a press fit. We take our nozzle over, come right up on top, and press it right on. So changing a nozzle is very simple. To remove it, I grab and pull it right back off. Obviously, if I just ran a profile, this nozzle will be very hot, so I'd use a hot pad not to burn myself. Also on the heater head, what you'll see is our vacuum pick. The machine does come standard with a series of 7 different sizes. I'll show you the range. This is the smallest vacuum pick, and this would be our largest vacuum pick. Obviously, we select a vacuum pick based on the size of the nozzle, or the size of the component that we're trying to either install or remove. The vacuum pick holds the component to do the alignment to the circuit board. It also acts as our Z sensor when we go to place the component on the circuit board. And then when we're doing a removal, we'll use the vacuum pick to remove the component as well after we have reached reflow. The top heater head is our Z axis. So it will be moving down to the board. It will carry the component down to the circuit board and place the component, or vice versa to remove it. And you'll see that later on in the demonstration. On the bottom side, we have our medium wave IR bottom preheater. And this is a series of heaters. We have a center heater, which you're not able to see, but it's basically taking this area here. And that heater is always active when I have a profile selected in the software. And then on the outer perimeter, we have 6 surrounding heaters, 2 on the sides, on each side, and 1 on the top and 1 on the bottom. So we have 6 additional heaters that we can use, that we can turn off and on in the software based on the size of the board and the thermal properties that we're dealing with. In addition, the bottom heater, it can always be controlled by temperature in the software, but it's also on a lift, and we can raise the whole heater up to the circuit board to be more efficient. So that's really important when we're talking about our thermally challenging applications. So let's talk about our board holder a little bit. Our machine holds a 24 by 24 inch square circuit board. And when we size our machine, we say 24 inches square, that means we can actually work the center point of that circuit board of that dimension. We have a fully adjustable board holder. We have 2 grooves we're working on. In the board holder, we have a V groove, and on top we also have an L groove. What groove we use will depend on the actual circuit board itself. If we have edge connectors, we might have to use the L groove, or if we have components close to the edge of the board, we may need to use the L groove on top. We also supply a standard with the machine, our odd-shaped board holders. We essentially have 2 right holders and 2 left holders. They'll mount on the rails accordingly. These can be used to, again, handle odd-shaped boards. boards with cutouts, edge connectors, and those types of things that we can't get on our standard board holder. Again, this will hold up to a 24-inch square circuit board. We also have our X and Y micrometers, which you'll see later on as we do our alignment for the component to the circuit board. That's a quick overview of the top heater and the bottom heater. As I said, our vacuum pick up top, getting back to the vacuum pick, that's used not only for installations but removals. However, in some cases, the vacuum pick on board may not work if the board's warped, if there's raised lettering on the top of the component, or if you have excessive surface tension. So we also supply, change sides here, our pick vac, and this is just a manual vacuum that we can use to remove a component from the board or just for component handling in general. I sometimes refer to that as Plan B. So also looking at the machine, obviously you see the emergency stop, which is on the front of the unit, our main power. We have 4 thermocouple input sensors that we use when we're developing our profile or for monitoring a profile to make sure that it's still working as we developed it for. So we can use up to 4 sensors, and they can be turned on and off within the software. So that's a quick overview of the unit itself. Obviously now you see the monitor attached to it. What you don't see is under the desk is the PC. That does come standard with the unit. Everything I'm showing you today does come standard with the unit. You receive 5 of the heater nozzles with the unit, sizes that you would select based on your requirements. As I talked about, the vacuum picks, the odd-shaped board holders, the PC, and there's a lot of other accessories we'll talk throughout the demo. So to show you a quick overview of the software, our software has 4 main tabs. We have a production mode, development mode, inspection, and setup. What you're going to notice in production mode, in this area, all I can do is select an existing profile that's already been developed. I'll go into my load profile area, click the little arrow, and pick the profile I'd like to run. Once I select it, all the settings change, and I'm ready to roll. So we use production mode for within your facility for the operators just to pull that existing profile. You cannot make any changes to it. There's no adjustments you can make in this section of the software. It's only select a profile and run it. What you will notice, in this case, I selected the mode as an installation. My placement is automatic. It can be automatic or manual, and we'll talk about that later on. I can have a flux dip active, where the component will be dipped into a plate of tacky flux or gel flux, or I don't have to use that. However, if I was in a removal mode, my mode would tell me removal, and I would have the choice of a manual or automatic liftoff. The biggest thing you are going to notice on this is the big green button, which is start installation process. And basically, as you'll see, the software takes you step by step on the movements of what the operator needs to do. And we'll talk about that moving forward. So that's the production, a quick overview of the production mode. When we go into development, it's going to look very similar. The only difference in development is this is where we can actually make changes to the profile. This is where we develop our profile initially. Keep in mind when we develop a profile, any changes we make, any settings we make here, any steps of the machine, once we set that, that sticks with that particular profile. So a couple things you're seeing on this screen, again, it's the same mode, placement, flux dip, etc. It's the same green button and the big red abort button if you need it. But what we have here is we have our profile zones. We have the preheat, the soak, the reflow, and the cool down zones. The orange line is my bottom heater set point. So we control the temperature of the bottom heater, as I said, as well as raising the bottom heater if I need to. Or I can come over here to the right and I can turn on those preheaters as needed based on the size of the circuit board and the thermal requirements. My red line is the top heater set point. So this is where I can determine what the top heater temperature actually is. Keeping in mind with this machine, I'm setting heater temperatures to try to achieve a target temperature at the circuit board. And we'll talk more about that in the profile development portion of the demonstration. My yellow line is the temperature setting for my auxiliary heaters. So that's universal for all 6 of the secondary heaters, the perimeter heaters. They're all in one temperature setting, which is independent of the center main heater. My blue line is my airflow, so I can also control the airflow, how fast that air and how much air is coming out of that nozzle under the application. And then my purple lines are my timelines, so I can click and drag to make these changes. So I can set my time, I can click and drag to set my temperatures. I can also go into what I call my profile manager and do the same thing. I have my top heater settings. So I can go on here and just type in a new temperature and it changes my line. I can use the up and down arrows, but it's quite honestly, it's a lot easier just to click and drag the lines on the profile. I can also do this, I can do this prior to starting a profile, or I can do it real time. So the nice part is I can be in the middle of a profile, see that I need more time, more temperature, or less, and I can make those changes on the fly, which we'll take a look at. The top lines here, these black lines, are basically just temperature reference lines that I can set in my setup screen, which you'll see. I typically use the bottom line as my solder melting point, in this case 220 degrees. And my top line is some temperature I do not want to exceed, in this case just set at 255 degrees. So that's just a quick overview of development. This portion of the software can be password protected, so those people you do not want making changes to the profile cannot access this area. Our inspection mode, the machine comes standard with 2 B and C connectors on the back. We're able to connect our optional X-ray machine. We can connect some additional source, whether it's a microscope or a look under scope, or we can just use the main camera. In this case, my ThermoFlo main video camera is being controlled. And I can go ahead and change my lighting. I can change my zoom. I can even go over to this side and take a picture if I'd like. So we can use the main camera actually to take pictures of locations on the circuit board. It's not really an inspection tool, but it's more of a reference tool. But there's a lot of built-in capability in the inspection mode. If we choose the X-ray option, we have a library of defect images for the X-ray as well. It's already built into the machine. Quick overview of the inspection. The last tab we have is our setup screen. This is where you would set your password if we want to block users from accessing the development screen. We can set our temperature units. The inactivity timers, as I said, when we select a profile, that main heater is always running on the bottom side. So we can set an inactivity timer for a certain period of time, in this case 30 minutes. If the machine sits idle, that bottom heater will set back in temperature to 100 degrees. Once it gets into setback, a secondary timer, in this case 90 minutes, will start, and once that 90 minutes is up, it'll completely shut off that bottom heater. So it's a safety issue. It prolongs the life of the bottom heaters as well. We can also select our languages here. We have 6 different languages to choose from for the software. Our temperature reference lines, which are those 2 black lines I referenced earlier, with the bottom temperature being 220 in this case, and the top line 255, the peak temperature we don't want to exceed. And our air source, in this case we're using air. We also have the capability to pump nitrogen in the back and run under a nitrogen blanket. The bottom is just our default profile folders, which pretty much stay the same. When we come to the right side of the screen, we have our prism calibration. I will make a comment that our prism is very robust once set at the factory. The prism is what splits the image when you're trying to do your alignment, which we'll talk about a little bit more in the future. One word of caution is a lot of customers, if they have an issue, they think the optics are off. They try to blame the prism calibration, and that's typically not the case. Probably 95 out of 100 times that's not the case. That is typically more of a focal distance issue, which again I'll talk about in the future, but the focal distance is something where we can adjust via software, and it is independent profile to profile. And then down below the prism calibration, we have our diagnostic section, which we can test the various sensors and movements of the machine. And last but not least, we have an error log, as well as an activity timer, or I'm sorry, an activity log, which will also allow you to track each and every movement of the machine. So for example, if you're having some type of an issue with the machine, you don't think the vacuum's turning on when it should, or the heaters aren't firing, we can start an activity log and use that as a diagnostic tool to help troubleshoot the machine. So that's a quick overview of the software and the hardware of the machine. Next up, we'll go ahead and do an alignment and a placement for you. So now what we're going to do, as I said, we're going to go ahead and start the alignment process. I'll show you the alignment process and placement of a component for an installation. So to do that, in this case, I'm just going to go to my production mode, and I can pull up an existing profile, which in this case I have my default installation, or I can go into my development tab, and I can pull up an existing profile here as well as with my open profile tab. I can select the same profiles, and this is where I can make modifications, or I can go in and say I want to do a new profile, if I'm going to do a brand new profile. So for demo purposes, I'll start with a brand new profile. So I'll select that. As you can see, again, my mode is installation, my placement is auto, up in the top left hand of my screen, and my big green button, which I'm going to keep referring to, tells me start installation process. So what I'm going to do is I'll hit my green button, and what you'll notice now is I'll receive a series of pop-up windows. In this case, it's saying please load PCB into board holder. So now I'm going to go over to this side. I can move my bottom heater down because I don't need it for this. So I'm going to go ahead and place my circuit board into the board holder. In this case, I'm going to use my V groove, which is now probably easier to see with the circuit board in there. We talked about it before, as opposed to my L groove, which is up on top. So what I like to do is I like to lock one side of the board holder so it doesn't move on me. Put my circuit board in. The right side, I slide my left side over. Now I have it nice and snug. So I'm going to slide the board up. I'm going to slide the whole board holder over to the center point. I'm not sure if you can see this or not, but there is a rough alignment centering laser coming out of the back of the machine that's focused on the center of the pads where I'm going to be working at. So I'm going to bring my board over and I'm going to lock it into place. So now my board's snug. I have my rough laser alignment coming down to the center point, and I'm ready to continue with the process. So I'm coming back to the other side. I acknowledge that I have my circuit board in. It's asking me if I remember to apply flux. At this point, I'm not going to apply flux for today's purposes, but I could either brush tacky flux on at this point, or I could turn the software on to actually do a flux dip, which is an automated process, which we can talk about a little bit later. But for the purposes right now, I'm more focused on the alignment and placement of the component. So I'm just going to acknowledge that. So what's happening now is my camera housing is coming out. It's telling me to load the component. What's happening here is the alignment camera is inside this housing, and it's looking straight out at you. And it's looking into a prism, which is splitting the image. So it's going to look up and it's going to look down. But in this case, it's telling me to load my component. So before I get to that part, I need to slide out my component nest. On my centering nest, this is where I put my component for the machine to pick it up. This is adjustable with a little thumb wheel here, based on the size of the component you're working with. So in this case, I open it up too much just to kind of stress the point. I'm going to close it down. I hold opposite corners of the component. Again, I want to size it just right. I don't want it too tight I don't want it too loose. So that component's sitting on there real nice. Now I have this proper sizing of the centering nest. I'll just pull that right back out. I'm going to put my centering nest onto the housing, and it locks into place where I need it to be. I will go ahead and put my component back on. And click OK. So the vacuum is going to come down, turn on, and pick up my component. It's going to tell me to push my component nest back, which I'm going to do. Again, the software is telling me step by step what to do, so it makes it very simple. I can push my component nest back. When I click OK, now the heater head's coming down and bringing my component to the proper focal distance. And the proper focal distance is having the bottom of the component the same distance from the camera as the top of the circuit board. So now I have my optics on here, my little viewing window in the software. I can zoom in on the component. Now I can change my lighting. The idea here is I want to be able to see both the pads on the circuit board, which you can see right now, the gold pads. I can turn my lighting down, my lower lighting down. I turn up the upper lighting, and now I can see the shiny solder balls on the component. I'll adjust my theta, so the part that's moving is actually the component on the vacuum pick, so we can see for my alignment purposes. So again, the first adjustment I'll make is theta to make sure it's level. I will do my X adjustment, and I can do my Y adjustment. The whole idea, it's that simple. The whole idea is to make sure that the solder balls on the component and the pads on the circuit board line up. So I'm very happy with that. We can see that very easily. Everyone's optics are different. Some people like more lighting, some people like less lighting. I'm sure the lighting in the room isn't helping right now. It's kind of washing out some of it, but again, it's very simple to align the component. I acknowledge my alignment is complete. The camera housing goes away. And at this point, the software, again, my big green button is back and telling me to place the component. In this case, we're doing an automatic placement where the head's going to come down. The component, when it reaches the circuit board, is going to trigger the Z sensor, which is built into the vacuum pick, and tell the head, hey, I'm here, the component's placed. Turn off the vacuum, release the component, which is what's happened. And at this point, I can start and go through my process. So next, we're going to talk about thermal profiling. And the most critical part about a thermal profile is understanding what target temperatures you're trying to achieve throughout the cycle. Ideally, when able, you're trying to mimic the original manufacturing process of when that circuit board was initially built. Typically, when it's manufactured, the manufacturer would pay attention to the specifications of the components, the solder paste, and the circuit board, and that profile would be very accurate for your application. That's not always possible, though. Sometimes you don't have control of what you're trying to rework. Other sources for thermal profiles, you can always refer to the solder specification. If you don't know what the original profile looked like, you can look at the component specifications, or you may have internal specifications that you're using that you categorize for all of your rework of printed circuit boards. So it's really up to you, the customer, to determine what that profile should look like. It's my job to kind of show you how to get there with our equipment. So we use some general guidelines when doing demos. We're working with lead-free circuit boards and components. So we're just going to target, around 150 degrees, basically anywhere from 140 to 160 degrees, but targeting 150 degrees coming out of preheat. We're going to target anywhere between 175 and 195 degrees coming out of our soak zone. And we're going to target a maximum temperature of anywhere between 235 degrees C and 255 degrees C as a maximum. Keeping in mind our solder melting point for lead-free is 220 degrees C. We want to make sure we do exceed that temperature by a minimum of 15 degrees, anywhere from 15 to 35 degrees, to make sure each and every one of those solder balls has reflowed and you got a good quality solder joint. So there is some variety and flexibility and ranges within these thermal profiles. The ramp rates will vary. The overall time of the profile will vary, and it's all really dependent on what your circuit board looks like. How thermally challenging is it? How big is it? The number of layers, the number of ground planes. These are all factors what that overall profile is going to look like. So again, you know, I want to help you achieve your target profile. So with that in mind, the key thing, as I said, is you need to understand what you're trying to achieve, but then you also have to have good feedback as you're developing your profile as to what the real temperatures are. Ideally, you have a scrap circuit board in which you're able to drill a hole into the bottom of it and attach a thermocouple to the solder joint, but in the real world that's not always possible. In this case, all I did was I took a thermocouple and slid the bead underneath our component. So we can take some temperature readings that way. Again, the profile that you develop is only going to be as accurate as the information you have being fed back to you. Okay? So with that in mind, we're going to go ahead and set up to do a removal process. With our equipment, ideally you have a component to remove to be able to develop the profile with. And then once you have that profile developed on the removal, you can simply go into the software, which I will show you, do a save as, name your profile by the board, by the component location, and as a removal, save it. Go ahead and make your change in mode from a removal to an installation. Save that now as the installation profile, and you have two profiles. So when you start running boards, you don't have to reinvent the wheel every time. You can take your base profiles on similar circuit boards and tweak and develop specifically for your application. In theory, every component on every board should have its own unique profile. In reality, a lot of those are very common and are general profiles that are interchangeable. But the idea is you need to verify what that profile should look like and what it does look like. So what I'm going to do now is I'm going to go ahead and develop a profile using a removal. So I'm already into a generic removal process. The first thing I want to do before I get started is I want to make sure I have a vacuum pick in. So the vacuum pick is attached in the center of our heater head, and it simply screws in. It's just finger tight. Obviously, if I had been working with this and I had a hot vacuum pick, I wouldn't be using my bare hand. So I have my vacuum pick in. I need my heater nozzle. And I'll just verify this is the correct one. I have my heater nozzle, and it's not, so I'll take the one from up here that I put up there earlier. I attach my nozzle. Again, it just presses right in to remove, pull down. So very simple change. So I got my component nozzle on there. Now I'm going to set some basic heater settings. Again, when I profile on this machine, I'm setting heater set points, both top and bottom. I'm going to determine my time for each of my zones, as well as my airflow. I'm going to set some basic guidelines before I start, and then as I develop the profile, real time I can make adjustments on the fly to achieve my target temperatures and times. So at this point, again, my orange line is my bottom heater set point. I'm going to leave that at 150 degrees. And my top heater is 120 degrees. In my soak zone, my bottom heater, is 160 degrees C. And I'll put my top heater about 180 degrees C. For this purpose, don't get too wrapped up into the temperatures. The heater output and temperatures are going to have different impacts on each and every application. Again, it's going to be dependent on thermal capability, or the thermal properties of the application, the size of the board, those types of things. So we're going to go ahead and just put this base profile in. I'll put my top heater about 230 degrees, and I'll make changes on the fly. So I have my circuit board with a thermocouple that's attached. I'm going to go ahead and put that into my board holder. So again, I will lock in my right side, bring my left side over. I'm going to slide the whole thing so that I'm within my rough laser alignment. I'll lock down my board holder, as we've done in the past. I will come over to the other side and connect thermocouple number 1. And I will turn that on. So now I'll go ahead and I will go through the alignment process to make sure that my vacuum pick is going to be in the center of the component when we do our removal process. So again, I have my removal selected. I'm going to go ahead and click my green button. Again, the green buttons and the pop-up windows will guide me through the process. Start removal process, and it tells me to please load the PCB into the board holder, which I have done. My camera housing is coming out. It's telling me to load the board again, which again I have done that. People like to do it at various times throughout the process. So now all I want to do is be able to see the vacuum pick so that it's somewhere in the center of the component. So I can adjust my lighting. And again, this doesn't need to be precise. You just need to be able to see where the vacuum pick is, again, the center here, versus the component. The other metal thing we're seeing is actually the component nozzle. So that's what you're seeing on the screen. So what I'm going to do, adjust my Y, adjust my X, and as far as I'm concerned, I'm in the center of the component, so my alignment is fine. Everybody's eyes are a little bit different. Some people like more lighting, some people like less lighting. When it comes to removal, as long as I can see the vacuum pick and the component, I'm not too concerned about it. So the camera housing has now gone away, and I'm going to click lower reflow arm. So now the head's going to come down. My vacuum pick is going to hit the component and trigger the Z sensor saying, hey, I'm at the board level now. So the head stops. Now I get a message saying use up and down arrows on main window to lower nozzle to cover component. So at this point I'm actually controlling the height or the distance of the component nozzle to the circuit board. So I will acknowledge that. I will step the heater head down. So I'm just off the board. I have a little gap in there, and again that promotes better thermal transfer and higher efficiency. Those 3 steps that I just put in moving the head down, once I save this profile, those 3 steps will remain with that profile. So once I develop this, it's not something I have to repeat. It will do it automatically for us. So at this point, I can go ahead and start heating. So I hit my green button once again. So my heater kicked on. You can start to see here, I'm starting right at the 100 C mark. So again, the beauty of this is I can make my changes on the fly. I can adjust my top heater again, which is the red line. So I bump that up a little bit. Now once I get partway into the zone, I don't want to make a lot of temperature changes. I'd rather make time changes so I'm more consistent when I run future profiles. So right now, 30 seconds in, I'm at 125 degrees and climbing. Keep in mind, again, we are setting heater temperatures to achieve target temperatures of the board. I'm targeting about 150 degrees C coming out of my preheat cycle. Again, that's going to vary by application. It's leveling off because I set my top heater temperature a lot lower because we're going to do more work with the bottom heat in our preheat zone. We're just making sure that circuit board gets up to temperature. Now that we're in our soak zone, we're going to be targeting in the 175 to 195 degree range. And again, we're doing a lot with our bottom heater, but we've increased our top heater as well, so we're putting more heat now from the top than we did obviously in the preheat zone. So we're getting that up to the next step to make it more, to make sure that all those layers of the circuit board are heating up. We do have a 5th zone that we can add to our profile, which we call a ramp zone. And this can be turned off and on in the software. A lot of times we can do a 4-zone profile, or we have the option to do a 5-zone for better control. So right now I'm at 190 degrees, so I can shorten my time because I'm reaching the temperatures that I want to reach. So I'm able to simply turn down my time or shorten my time on the fly, which makes this a very easy process. Now my reflow zone, I'm going to be targeting again 235 to 255. So my top heater at this point is 230. I'm going to go ahead and bump that up to about 245 degrees. My black line is my reference line, and that is set at 220 degrees, which is solder reflow. We're going to be above reflow for anywhere from 30 to 60 degrees. And again, that time varies based on which technical bulletin you look at, or what specifications you're dealing with. So what happened here is we probably hit reflow at this point. The temperature peaked and dropped off. Probably what has happened is my thermocouple took a little movement, which is why the sudden change in temperature. So that beeping indicated we're within 5 seconds of the end of the cycle. As you can see, at the end of the 5 seconds, the vacuum turns on, and as you can see, the vacuum is removing the component. Now it's important that I allow my profile to finish out and continue with the cool down cycle, so that if I had a fully populated board, if any other components did reach reflow, that we're not going to disturb them by moving the circuit board. So now that we're getting down to the end, at the end of the cycle, I'll receive another message saying that the cycle has ended. The vacuum will continue to hold my component until I acknowledge the command. And I want to be very careful to make sure I have something ready to catch a component when I release the vacuum. So right now it's telling me click OK to release component. Caution, component may be hot. I hope it's hot. So I'll go ahead and put my component catcher underneath, click OK, and my component is now removed. Okay. So as you can see, using the TF2700, it's very simple, it's very user-friendly, it's very interactive. Profiling with the on-the-fly adjustments you can make allows you to be successful within the first or maybe second time you try to develop a profile. Again, the keys to that are understanding your targets, what do you want that profile to look like, and 2, making sure you have good thermocouple placement and you understand the information or what that solder is actually, those temperatures the solder is achieving. A couple other things I'd like to show you, which is one of the great tools we have on here. I ran this in development mode. However, if you ran in production mode, I'll get back to my production screen. I can actually take that profile I just ran and create a report on it. So I can go into my record manager and track it. As you can see, we have a picture of the profile we just ran. But if I create it as a PDF report, I give it a name, ABC, and save it, I now have a production report. So it tells me what my heater settings were, top and bottom, tells me my times, my flow rate, and it gives you a copy of the profile that was run for that specific application. So if you have quality issues or you need tracking purposes, we can certainly do that on this machine as well. So just a nice little onboard reporting tool that we offer. Okay. So again, I just wanted to show you that. I thank you for your time. I thank you for your interest in PACE and the TF2700, and hope to see you soon. Thank you.